Hello everyone, I'm Jianan Shen, and my part of the job in the CPC project is to look at the GPS movement data of police officers instead of, especially the officers in foot patrol operations. So the goal of my research is the space-time cognition of officer subgroup behaviors. What it means is that we're going to firstly find out the place and the time periods that the officers are specifically interested in their patrol activities, and then generate a profile to describe their behaviors. And based on these outcomes, we can group the similar officers with similar profile of behaviors together, and have a status check, and also this can be used for supporting their performance evaluation. And thanks to the infrastructure improvement for intelligence policing, we now have the APL system, the automatic personnel location system. What it does is that it will tell you every individual officer in active duty their location every 5 minutes. And this data set also will tell you other extra information, such as their job types and their status information, such as what they're doing, whether they're resting or on watch or patrolling or in office. And this system is originally used for controlling and dispatch officers to tell the control center where the officers are, and we now use it for analysis. So the idea originates from a very common idea in human dynamics. It is where you stay is who you are. So people from different cultural backgrounds and working types and different personal characteristics can visit different places. And the type of places they visit represent the personal characteristics of these people. So the more common places they visit, the more similar they are. This is the very basic and simple assumption here. But it has been proven in location-based social network to be simple but effective. But it has a very huge limitation. That is, it cannot describe the real-world scenario because it's a lack of temporal information. So you don't know when they visit the place and how long they stay there. But of course, this time information is very important also in looking at different people. So that's why we evolve from that idea to a new idea called when and where and how long you stay is where you are. So this is also the same in the patrol behavior of the officers in the urban network. So they visited the place, so different officers, because of their working types are different, and maybe the missions given to them are different. They may be focused on different types of places, and but at the same time, they may be in active duty at different time periods in the daytime. So, and given the social background, their activities may be very, very different. So the first step for us is to look at not just the places the interesting places, but also the places with temporal information. So a place won't be of interest of all the time. Say a market maybe is attracting a lot of tourists in the daytime, but when it's closed, nobody visited, and it's not a region of interest anymore. We developed an algorithm called network-based space-time density clustering algorithm, STDB scan. We use it to find out the places and time periods with high density of stay points, of high density of user visits. Yes, and basically you just need to set up a spatial distance measure and a temporal distance measure, and it will create a scanning window for you, and will scan the road trajectory, find out the stops and high density places and time periods of stops, and generate POIs not just in space, but also have a time information. So every region of interest has its start time and end time. And of course, they have their semantic meanings because they have their own functions, so that we don't just describe a place with words like bars and underground station. We describe them by bars in the afternoon and stations in daytime, and maybe a convenience store in the early morning. And also, another advantage of this algorithm is that density clustering can detect the region of interest of different arbitrary shapes. So by using density-based clustering and network distance, we can actually reshape the region of interest into the urban network structure, as my colleague has been talked about many times today, that all the officers, all the basic human dynamic movements in urban network are actually in street networks. So that it makes it more closer and more similar to the real world scenario. And after we got all these RCROIs, we want to see how different how individual officers spend their limited time budget on different types of region of interest. So because they have different emphases because of their maybe job type differences or their mission differences, they may consider different types of region of interest differently. So that's why they are allocating if every individual officer have 8 to 12 working hours every day, so they will allocate their limited working hours in different types of places. And we build up a profile, we call it space-time profile, to describe the behavior, staying behavior and POI visiting behaviors of all these officers. And basically the profile will look like this. And say if there are 28 space-time STROI in total, and one officer spend their amount of time like this, and all this time is calculated in percentage and sum up to be 1. And these profiles will act like DNAs to distinguish these officers, just like what the biographers used, just like what researchers in biology used to distinguish the probabilistic distribution of different components in genomes. We can use this as a DNA to distinguish officers, and each component of here is the different types of region of interest. And we also use this equation here to calculate the differences between these two profiles. So it's very complex, but all you have to know is that it's quantify the differences of two profiles. And we can get the distance, or we can call it dissimilarity of every two profiles of officers, and for all the officers. And based on this pairwise distance, or you can call it pairwise dissimilarity, we can use a hierarchical clustering to generate groups of officers, so that officers within the group will be more similar to each other, and between the group will be quite different. And this is a case study. It's a Camden area, and it's been shown for several times. Based on the traditional spatial method, it can only tell you the region of interest in a space, and you don't have the time information. But what we see when we visit the police station in Camden, on their poster, is that they're actually focusing their police resources, the police force, on peak time and peak time periods and peak areas. So temporal information is playing a significant role here as well, so we shouldn't ignore it. So this is based on our improved method, STDB scan. We can actually find out the region of interest like this, with its lifespan on all these ROIs. And again, it's map matched. And it's much more, this model is much more time sensitive than the previous ones, and that it can be able to detect some issues that very time sensitive. Like this one, if you look at the data in January, we don't have the space-time region of interest outside Camden border, because police officers are very rare to come out of their borders as their work, in their work. But when we look at the February's data, we accidentally find out a very significant region of interest, space-time region of interest outside its border. And when we look it up on the news, we find out that it's a humanitarian crisis in Syria, causing a lot of protests surrounding the Syrian embassy in London for the entire month and all day long. And when we group these similar officers together, we will generate several subgroups of these officers. And just like what I showed, the round tree-like structure, grouping similar users together, you can see here we show we visualize the state points of each subgroup we generated here. And you can, and because of this is a sensitive data, and because we're short of time, we just show you two examples here. One is subgroup 2 we generated, and subgroup 3. You can see that their interest, the time periods and the place they're interested in are quite different. We're actually able to find out the subgroup that are specifically interested in the Syrian embassy in February. And we also validate our result by looking at other information, such as status information in this APLS dataset. And you can see that how the status varies when these two subgroups behaviors are so different. Like subgroup 1 here, most of them are assigned with a job, means that they have been working on daily jobs. And also, they have relatively high limited availability. High limited availability. But you look at the police group that were dispatched to reinforce the Syrian embassy, you will see that most of them are with vehicles. They are going there by vehicles because it's simply far away from their stations, and you can see a lot of difference here. And you can see how different their working type is. There are even more significant differences in their working types. Subgroup 1 here is just a very normal daily job of typical local police. So you can see the percentage of community support officers. They are concentrating their manpower on the local areas, especially the center of Camden, in the afternoon and late at night. And some of them are foot patrol officers. And you can see that nearly all of these officers that are ordered to go to reinforce the Syrian embassy are foot patrol officers. So maybe just a guess. I don't know their working regulations, but maybe the foot patrol officers are only allowed to go out for this temporary task. And basically, what we did here is that we further developed the traditional ideas and the methods to make more sense, to dig out more information on the same data set, and it's capable of profiling different police officers when they are going out on patrol, and the results show that this is demonstrating more. This model is more similar and closer to real world scenario, and this can also be used to evaluate police behaviors to see whether different group of officers, whether they are going to the region of interest that they are told to go to. And also it can have a potential to detect outliers and abnormal behaviors. This is the demo of the interface. So it's very mobile device friendly. So the technology developed it can actually enable it to be transplanted to a mobile device such as iPhone or Android without any modification. And basically here is that it shows has two modes. The overall mode will show you all the SDLIs, and the subgroup mode will show you the state points of different generated subgroups. And you can see that and color them differently. And you can see each subgroups, you can see the ID of officer in each subgroups to further look at whether they are doing their job or not. And you can see in the corner here, there are three very small subgroups with different color. Each of them form an individual subgroup. So it's a group that with very little number of people, and what makes them quite different from other officers are very interesting, and you can look at it and see whether it's abnormal behavior or not. And that's all. Thank you.
Do we have any questions?
Hi, just a quick clarification question. Thank you for the really clear discussion of that, and it's very interesting. Clearly applicable to understanding like how people are moving around the city. But you define these like ROIs,
Yeah.
and that was how you saw like the percentage amount of time people were in each place. I'm sorry, I just missed how you define the ROI. Like how do you find the bins within which you count how long the officers are in them?
Yeah, you basically, because the region of interest are generated by the movement data set. So it's actually the high density area of police officers staying for a very long time or very often. So you can see it's every region of interest that actually generated by scatter points, or by state points of officers. So you can see each officer in this region of interest. You can see when they arrive there and when they leave there, how long they stay there. That's how I find out how long they stay there. Is that?
Do they stay the same over the entire analysis?
Sorry?
Do these regions of interest stay the same over the entire analysis, or do the locations of the regions of interest change over time?
Yeah, it's changed. You can see that there are new regions of interest popping out in February, and that is the Syrian embassy. And you can see as the time goes on, and the location will change because of different issues happening. And also, I think they have the police officers have a strategy called hotspot policing. So when the crime hotspot changes, they will change their focus as well.
One more question from the front.
Hi, I thought really interesting. The question that occurs to me is, how do you, sometimes the officers on patrol will be going to an area because they've been told to, because there's an incident they've been called to. Sometimes they'll choose to go there because they want to do some proactive policing. So how do you distinguish visits and stays that officers actually choose themselves to go to or are assigned to because they've been called to a specific incident?
I haven't dealt with other data sets, but I think there may be some dispatch data sets to tell you whether an officer is told to go there, or if it's not, then maybe we can assume that it's a decision made by himself or herself.
Mm.
I think,
Okay.
but I haven't dealt with data set like that before.
Thank you.
Okay, we'll move on now. Thank you very much.